Hi, this is chapter 10, number 70. We have a cylinder. The cylinder is starting from rest and rolls down a ramp. So we're going to use the conservation of energy to find how fast it's moving when it reaches the bottom. Now, conservation of energy, let's see, so it's potential energy plus kinetic energy before equals potential energy plus kinetic energy after. But here's the thing. We know that it has zero kinetic energy here, so alright, that's fine, we can cross that. And the potential energy at the bottom is zero, so we can cancel that out. But there are two kinds of kinetic energy. It's moving two different ways. At the bottom it's rotating, and its axis of rotation has moved from one point to another. That's the translational motion. So actually, that's the same as what we're used to, 1/2 mv squared. So we've got mgh equals, we're used to, 1/2 mv squared. But we also have to take into rotational kinetic energy. And that is 1/2 times the moment of inertia instead of mass, and instead of velocity, angular velocity squared. Okay. The moment of inertia for a cylinder is 1 mr squared. There we go. So let's plug that in. We've got mgh equals 1/2 mv squared plus 1/2. Don't forget the other 1/2. I did that before. Messed me up. Omega squared. Okay. So, we do some fun stuff. Divide out the masses. It's all the same mass. Now I made the limit. It's really the same mass. Okay. Next up, notice we have left. We've got gh equals 1/2 v squared plus 1/4 r squared omega squared. R times omega, does that look familiar? Rotational, the velocity, tangential velocity is omega times r. So if we square it, that's what happens. We could write this, gh equals 1/2 v squared plus 1/4 v squared. Very nice. I like 1/4 plus 2/4. 2/4 is the same as 3/4. So gh equals 3/4 v squared. Solve for 4/3 gh. Square root the whole thing. Equals v. G is 9.8 meters per second squared. The height is 7.0 meters. So velocity turns out to be 9.6994852 meters per second. Sigs, They only gave us one number. That's the numbers. So the velocity is 9.7 meters per second.